In this video, we'll look at the conceptual models used for the Glimmerus and Vibrio parahemolyticus and oysters risk assessments. Bear in mind, we're presenting a generic risk assessment model in the course. Different communities of practice may tweak that model to better suit their own purposes, or they may have previously developed a model that suits their own needs. So please know there's an infinite variety possible in the number of conceptual risk assessment models that exist. You should see the consequence and probability dimensions of a risk at work in each of these models. Let's begin here with the Glimmerus risk assessment. Here we have a definition of risk that says risk may be defined as the expected likelihood of an undesirable outcome. So we've got probability and consequence there. Risk may be defined as the expected likelihood of an undesirable outcome occurring as the result of exposure to a stressor that can induce an adverse response. Thus, risk is a function of the level of exposure to a stressor that may occur and the effects that may be incurred with exposure to the stressor. That risk is written as shown right here. Risk equals adverse impacts. The risk of adverse impacts is equal to the exposure to the stressor plus effects of the exposure. I personally have had difficulty with this equation and suggested that it be changed to multiplicative on a number of occasions. Note that the effects of the exposure is the consequence, and the exposure to the stressor, that's what describes the sequence of events necessary for the effects to occur. If either one of these two components is zero, there is no risk, and that's not obvious in this additive form. So I have some difficulty with the definition. Let's scroll on down just a little bit here. Once the conceptual model is detailed, as we see here, the more traditional equation appears. Up at the top, we see the risk of adverse impacts occurring as a result of the establishment of an aquatic nuisance species is equal to the probability times the consequence. When the simple model is unpacked in the detail below, we see the familiar elements of the model. We begin by identifying all the aquatic nuisance species in the Great Lakes and exclude those that are already present in both basins or unlikely to reach the new basin. The remaining aquatic nuisance species are the ones that we perform a risk assessment on. That risk assessment has two components: the establishment assessment and the consequence assessment. The establishment assessment is the probability piece. That's the likelihood that the species will become established and spread. And then the consequences, of course, follow on as a direct result of that spread. Here you see the 5 components of establishment: the probability that a pathway exists, the probability that an aquatic nuisance species arrives at the doorway of this pathway, the probability that the aquatic nuisance species, once it arrives, survives passage throughout the pathway, then the probability that once an aquatic nuisance species has passed through the pathway, colonizes, and then the probability that a colonized aquatic nuisance species will spread. If all of that happens, then the consequences on the right, environmental, economic, and social political consequences, can be expected. These two elements result in a probability of establishment, an overall consequence, which when taken together comprise the risk of establishment of an aquatic nuisance species. These risks can then be examined by the species itself or by the pathway. This is a rather unique conceptual model, but it could clearly be reused for other aquatic nuisance species assessments. Now let's consider the Vibrio parahemolyticus in oysters model. In the last module, we presented this Codex risk assessment model as part of the risk assessment history. We're going to go now to our Vibrio parahemolyticus model, and let's fast forward to page 27 here. And we see the risk assessment overview. And here we can read very clearly that the structure of the risk assessment consists of 4 components: hazard identification, hazard characterization, exposure assessment, and risk characterization. This is precisely the Codex model. If we scroll down a couple of pages, here we see the model played out in a little bit more detail. Whoops, excuse me. So we have the hazard identification and some detail elements, the hazard characterization with some data and modeling details. The exposure assessment shows some data and modeling details. The results of these 2 pieces, hazard characterization and exposure assessment, are pooled together in a risk characterization which identifies the number of illnesses, the severity of illness, the uncertainty and variability analysis, and it also includes model validation. After that's completed, the uncertainty that has remained to this point is explored in what if scenarios. So our takeaway point from all of this is really pretty basic. Good risk assessment requires a conceptual model. A good conceptual model takes you from the hazard to the undesirable consequences, or from an opportunity to the uncertain but hoped for consequences. Different communities of practice will use different conceptual models. If you do not have a conceptual model, you can begin with the one on page 102 of the O text. One final point. Do not confuse the conceptual risk assessment model with any calculation or estimation models that are used to conduct the risk assessment.